Welcome to Hartman Math. This is lesson 6-4, right triangle trigonometry, part 2. We're going to focus on applications of our previous lesson, which was finding missing side lengths in right triangles, given an acute angle and one of the sides. So just a reminder how we look at and place things in regards to an acute angle in a right triangle. We've got opposite side, we've got the leg that it touches the angle in question, so that's the adjacent leg or adjacent side. And then the longest side, always opposite the right angle, is our hypotenuse. We've defined sine of theta to be the opposite leg length divided by the hypotenuse. So, and cosine to be adjacent divided by hypotenuse. Ca and tangent of theta to be opposite divided by adjacent. Toa, so katoa was our mnemonic device to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And we're really focusing on our situation, being able to identify which is the opposite side, which is the adjacent side, which is the hypotenuse. Before we get into some problems, a little bit of terminology that we need to go over that's popular in some application problems for trigonometry is the concept of angle of elevation. So angle of elevation, the key thing here is that particular angle will always touch a horizontal segment. Okay, so it's always going to be from the horizontal, how much would we elevate? That's the angle in question. How much does it elevate from there to there in that sight line from the horizontal? It never touches a vertical. The related concept is angle of depression. So basically that's when you're looking down on something. You're high up, you're on a mountain, on a cliff, on a tower, on a ladder, whatever it is, and we're looking down on something. So it touches a horizontal. So from the horizontal, how much is it bent down here? A lot of people want to have it be this angle here. That would be a mistake. Okay? It's from the horizontal. So horizontal first, and then how much do we depress that horizontal to see what we're looking at? So both angle of elevation, angle of depression touch a horizontal. Example number 1, we will ultimately round to one decimal place. We're also going to include units. We're going to start by making a sketch. We'll talk about that in a moment. Here's the problem. The angle of elevation from a point that is 30 meters from a tree to the top of the tree is 52 degrees. How tall is the tree? So we want to draw a sketch that involves the tree. It's got all this stuff in it. In the sketch, we need to label. We need to have a right triangle in there. We need to label the known quantities, things like 52 degrees to 30 meters, and also what is it that we're trying to find? How tall is the tree? The height of the tree. That part gets labeled with a variable. So those are the requirements of your sketch. Go ahead and pause it here. Come up with what you think is that sketch. Hit play when you're ready to see. Our sketch should look like this. We've got our tree. We've got a point on the ground that is 30 meters away from the tree. The angle of elevation touching a horizontal, which is the ground, elevates, rotates 52 degrees up to the top of the tree. So 52 degrees elevates up to the top of the tree. Here's our right triangle. So then we've got to figure out, as it's not a special right triangle, it's a 52 degree angle, which is the trig function that we're going to use. Here's what we either have or are trying to find. Here's our angle. We've got opposite, is what we're trying to find. We've got adjacent, which is known. We've got opposite and adjacent. So we've got to think back to so katoa, which one involves opposite and adjacent, and that's tangent. Notice the hypotenuse, we're not trying to find it. We don't know what it is. We don't really care about it. So nothing involving hypotenuse. So again, that lands us on tangent. Tangent of 52 degrees is equal to opposite over adjacent. That's our setup. And then it just becomes a solve. We're going to solve for h. We're going to undo the divide by 30. We're going to multiply both sides by 30. H is equal to 30 times the tangent of 52 degrees. Type that into the calculator. We're going to round to 1 decimal place. We're going to use our units here. So we're going to say that's going to be approximately 38.4 meters labeled. 1 decimal place. Height of the tree. Okay. So a little bit more than 100 feet tall, if we're going to talk about in standard unit of measure. Example number 2, Rapunzel's tower is 82 feet tall. How long is the shadow that it casts when the sun is at an angle of elevation of 71 degrees? Again, pause here. Try to sketch it out. Make sure we have 82 labeled in your sketch somewhere. Make sure there's a right triangle. Make sure there's a 71 degree angle. Make sure there's a shadow. And we're trying to find how long is the shadow. That's what we're going to label with the variable. So pause it here. Here's our sketch. The sun comes down, hits that, creates a shadow on the ground. The angle of elevation from the ground has to be touching a horizontal. Up to the sun, which touched the tip of the tower, is 71 degrees. We don't know the length of the shadow. We do know the height of the tower to be 82 feet. So let's see if we can figure out which trig function we should be using. Here's our acute angle. We've got 82 as our opposite. S is our adjacent. Sounds like tangent once again. Tangent of 71 degrees is opposite 82 over S adjacent. We're going to solve this. A little bit trickier with the variable in the denominator, but we approach it the same way. We want to undo the division. So to undo divide by S, we're going to multiply both sides by S. These will cancel. We've got 82 on the right side. Trying to get S by itself. This is S times tangent 71 degrees. We're going to divide by the tangent of 71 degrees. Now we're ready for calculator. Type that into your calculator. Again, make sure we're in degree mode. Previous user might have put it in radian mode. Make sure it's in degree mode. Type it in, and we're going to get that's approximately a shadow that is 28.2 feet long. Example number 3, Kelly is flying a kite at an angle of elevation of 70 degrees. The string on the kite is 65 meters long. How far is the kite above the ground? Go ahead and pause here while you sketch. Make sure we have the 70 degrees in there, the 65 meters, and something for the distance the kite is above the ground. Your sketch should look something like this. Distance above the ground, that would be the height of the kite. We know the string length. We've got Kelly here, and so the angle created with the horizontal, again, must touch a horizontal segment, not a vertical. That's the 70 degrees. All right, so we've got a successful sketch. Now we want to set up a successful trig equation. Here's what we have. H is the opposite. 65 is the hypotenuse. So we're dealing with opposite and hypotenuse. O and H. I think that's the sine function. So katoa, sine is opposite over hypotenuse. So the sine of 70 degrees is opposite the H divided by hypotenuse, the 65. All right, let's undo our division. Let's multiply both sides by 65. Cancels out. H equals 65 times the sine of 70 degrees. H is by itself. That must mean we're ready to type that into your calculator. See what you get. Approximate to 1 decimal place. Include the units. H is about 61.1 meters off the ground. Example number 4, Matt is standing on top of a cliff 305 feet above a lake. The measurement of the angle of depression to a boat that's out on the lake is 42 degrees. How far is the boat from Matt? The sketch might be a little bit more complicated here, so let's take it a little bit slower. What we do know is that we have a cliff, we have a lake below, and Matt's on top of the cliff. And there's a boat out there. And then we're talking about angle of depression to the boat coming from Matt. And that's the important part. The angle of depression is going to the boat, but it's coming from Matt. So we're going to start drawing our triangle here. We're going to draw it. Remember, angle of depression, angle of elevation must touch a horizontal. So we're going to draw that horizontal first. There's our horizontal. Trying to make a right triangle. So here's our horizontal, and let's connect it down to our boat. And back to Matt. There's a right triangle. Now let's see if we can label the thing. So see if you can pause here and label. We got 305 as one of the sides of the right triangle. 42 degrees is somewhere. And then we want to know how far is the boat from Matt. It's kind of a tricky thing, so we'll get to that too. So go ahead and pause, see if you can place it, and then hit play when you're ready to see if you can check, are they right. So the 42-degree angle is here from the horizontal. It's the only angle that touches a horizontal here that's not the right angle. So this is the 42 degrees. 42 degrees bent down so that we see the boat. 42 degrees. The cliff is 305, but that's not one of the sides in the right triangle. But straight across, if this is 305 and this is horizontal, then this also has to be 305. So that's 305. And then the tricky part is the distance from Matt to the boat. This is the distance that we want, the straight line distance. It might be a different problem to say how far is the boat from the base of the cliff. That would be this, which is essentially this length in our triangle. That's a different question. We want to know from Matt to the boat, that's this distance right here. So we'll label that with a variable. I chose D, you didn't have to. So here are the 3 things in our triangle. Now let's solve for D. We've got, let's see, 42, we've got opposite, and then we've also got hypotenuse. Again, it's a sine problem. So the sine of 42 degrees is 305 opposite over hypotenuse D. Let's undo the division. Let's multiply both sides by D. D times the sine of 42 degrees equals, cancels out 305. Now we want to get D by itself. Undo the multiplication. We'll divide both sides by the sine of 42 degrees. We will type that into a calculator. We're going to get D is approximately 455.8 feet. Make sure we have the units. That's it for today. I'll see you next time.